Welcome back, students. This is going to be the last topic of the series, More and Mealy machine. And in this topic we will try to convert More machine to a Mealy machine and Mealy machine to a More machine. In case of NFA and DFA, DFA doesn't require to be converted to NFA. Every DFA is an NFA, and every NFA, whereas every NFA has an equivalent DFA. But in case of More and Mealy machine, both have equivalent. More have equivalent Mealy and Mealy have equivalent More. It means we need to do some extra steps to convert the machine from More to Mealy and Mealy to More. So More to Mealy is very straightforward and very easy. There is I haven't found a single case where it is a little tricky. For example, if you have a More machine, so you want to convert it to Mealy, so this is the only case you have. So you just have to take care of incoming edges on the state. So because this is the state giving an output, that is why this is a More machine. And when we have to convert it to Mealy, so this state, the output will be removed, and whatever the incoming edges have, the same output will be transferred to the incoming edges. So every state have to will have to find the incoming and outgoing edges. For example, this is a state and you are going to another state here. So this state have this one incoming edge. This has the incoming edge, and this is for this state, this edge is the outgoing edge. Outgoing edge is the edge is leaving the state, and incoming edge is for example, for this state there is no incoming edge, and for this state there is no outgoing edge. If there is a looping edge, like this state is looping, so the loop is also considered the incoming edge. So when you are converting from More to Mealy machine, you all have to take care of incoming edges. You don't have to worry about outgoing edges. So for example, there could be a case like it is going to so many other states, but you don't have to worry about those. Only you have to take care of incoming edges. So all the incoming edges will be labeled output as T, and this T will be removed. You can see here. So let's take the example. This is the example with the 4 states: Q0, Q1, Q3 and Q2. So if we want to remove the output at Q0, so we have to see the incoming edges. There are no incoming edges, just very straightforward, remove the output 0, and here the Q0 is written. When you are at state Q1, you have to see all the incoming edges. There is only one incoming edge, that is this one. So you put the output, you put the output 1, and then you remove this. So when we come to Q2, find out the incoming edges. How many incoming edges are there? 1, 2, and this is 3. There are 3 incoming edges to the Q2. So if you want to remove this 0, so this should be 0, this should be 0, and this should be 0. Then you can remove this. Okay, so how many incoming edges to Q3? Again, 1, 2 and 3. So A1 to 1, B1 to 1, this A1 to 1 and this B1 to 1, then you can remove this. This is very easy, very straightforward. So in exams, for sure, I might give you 1 or 2 points objective for More to Mealy, but I will not give you a heavyweight question. Here comes a tricky example. When you have to convert Mealy to More machine. Why it is tricky? Why it is not straight? There could be a straightforward case. For example, just take the example of this machine. For A, there is output 0. For B, the output is 1. For A, output is 1. And for B, output is 0. So this is a very straightforward example. There could be a very simple cases when you are converting from Mealy to More. So all you have to do, 2 states, let's say this is state A, This is state B. Just find out how many incoming edges are there. This is incoming edge, this is incoming edge, and both edges are giving 0. So here A will give output 0. This is the initial state, and this is A, and this is B. So how many incoming edges are there? 2, and both are 1. So this is again very straightforward. Put B to 1, and this is B, and this is A. This case is very easy. We converted an NFA to NFA from Mealy to Mo. This case could be a very easy case, but unfortunately in the exams you will not be seeing this type of cases. You will be seeing this type of cases. For example, for 0, output is small a, then this is state B, and if you come B, for 1 the output is B, and again for 0 the output is A, and I just keep it simple. From 1 output is A. So this is a very small case where we have a situation. The situation is this is state A and this is state B. So the situation is, to A there are 2 incoming edges and both giving the output A. So this is very straightforward. When you convert A, output is small a, and these edges are easily labeled. Okay, but the problem is with this B, because B has 2 incoming edges and one is 1 and one is 0. So what should be the output of the B? We cannot decide this. So what we do, we divide the B into B1 and B2. So when you are coming from 1, so it should be the output 1, and for this B it is 0 and output is 0. And outgoing edges, the incoming edges are now balanced. Now outgoing edges has to be balanced. From B there were only 1 output edges, that was 1, so you will have to do this as well. Now it is a balanced NFA Mealy to More machine. When we have a situation for B, you could like for this we have a different output incoming, and from here we have different output incoming. So we divide the states into 2 different states and then we balance it. Now this is, see, in this case we have a loop back, but here we will not have a loop because the loop edge was giving the output A. So so this was given the output 0, so this is the loop will be here, but here we will not put the loop. Okay, so if there are two different edges are coming with different outputs, then we will divide into 2 different states. If there were 3 incoming edges and all 3 are different, then of course we will divide B to B1, B2 and B3, and then we will try to label it. So let's get back, and this is again the example. Let's see on the slide. We have a Q4, we have 2 incoming edges with 0 output and 1 incoming edge with the 1 output. So we divide Q4 into Q41 and Q42, one with 0 output and one with the 1 output, and then we balance it. Like all the edges 0 should point to a state with output 0, and all the edges with 1 should point to the state that is giving the output 1. and again the outgoing edges should be balanced from the both states. So A1 was this was outbound, and this should be given to the both states. For example, A1 is the outgoing edge, B1 was the outgoing edge, so we have just label all the outgoing edges to all the new states. So another case could be, we must consider the incoming edges, outgoing edges, and loops. Loops are basically the incoming edges. The loops is a category of incoming edges, like I just gave you an example. So for example, consider a case A1 giving output 0, B is giving output 1. Again, Q3 will be divided into two states, Q31 and Q32, Q31 and Q32. So A was giving the output 0, so A should point to the state which is giving now the output 0, and B1 was giving output 1, so the B will loop here. Though B was looping in Q3, we will not put a loop back edge on this. Why? Because B3 was giving the output 1, so it has to be pointed to the state where the output was 1. So you just take one or two more examples, simple examples, and you try to balance it. Once you learn to balance one state, then you take the example where there are more than one conflicting state. Consider this example. It has Q0, incoming 0 and incoming 1. So this is, like, I'm just pointing, like, this is the conflicting state. In case of Q1, it is a straightforward. There is only one incoming edge, that is 1. Q3, there are only one coming edge, that is 0. So this state is very easy to balance. Just put 0, just put 1. Sorry, the connection was disconnected. So Q3 and Q1 are the straightforward cases, and we can easily label this. But however, Q0 and Q2 are the tricky one. Why? The Q0 have incoming edge with 0 output, and B with the 1 with the another output. So Q0 had two different incoming outputs. So that is why Q0 will be divided into two parts, and again Q2 will be divided into two parts. Why? We have 0 incoming output and 1 incoming output. So when we convert this, first we divide Q0 into Q01 and Q02. So Q01 has the incoming edge from Q1 with 0. So Q1 with 0 will only come to Q01, but it will not come from Q1 to from this state. Why? Because this A was giving initially the output 0, so it should come to the state giving the output 0. And there was another edge B1. B was giving the output 1, it was coming from Q3, so the Q3 state will point to the second part of the Q0. Then we have to balance the outgoing edges. Outgoing edges was 1, that was going from Q0 to Q2, and another outgoing was from Q0 to Q3. So these two edges should be added to the both parts. From Q0 you will be going to Q2, and from Q0 you will be going to Q3. Alright, and this is how it is balanced. But when it comes to Q2, again Q2 will be divided into two subparts, and the edges, for example, let's say from Q0 you are going to Q2 with output 1. So when the Q2 will be divided into two parts, in the two further states, for example, this will be divided into Q21 giving output 1 and Q2 giving output 2 and 0. So this edge, from Q0 that is coming to Q2 will come only to the state, which part? It will come to the which part? It will come to the part where the output is 1. From Q0 you will come to the output is 1, this one. But you will not have an edge from Q0 to this subpart. Why? because this output is 0. So this from Q3 you will have a incoming edge to Q2. So you just take one or two more examples from the net, YouTube, or from the book, and you try to solve it. If you have further confusion, you may ask on the LMS, and I will explain this again with more examples. But I want you to explore it and learn by yourself so that your self-learning capabilities are increased. Okay guys, thank you. And the next lecture, the next series will be the context free languages. This is very funny, or not very funny, very interesting. Context free languages and context free grammar, CFGs and CFL. If the concept on DFA and FA are clear, then we can easily understand these two concepts, because these are little advanced concepts compared to DFA and NFA, finite automata. Now we are converging to understand the languages which are not regular languages. So for every regular languages we have a finite automata, DFA, but when the languages are not regular, then how do we handle? We handle by CFGs and CFL.